All right, now that we've done our experiments, let's actually come up with a formal way of finding our asymptote lines without having to make tables or graphs or anything of that sort. So, to determine your horizontal asymptotes, your rational function has to be in what we call a polynomial form. This will give you all y concepts. There's going to be another one in here as well. So you'll notice that in my polynomial function, I included the first term and the last term. I don't care about anything else in the middle. So like I said earlier, this is my numerator. My denominator, I call it capital N of x over capital D of x instead of capital P and Q. So I can find my horizontal asymptotes by just looking at the leading terms. And you compare the powers. So n being the top power of the numerator function on the leading term, if that is less than the bottom power on your leading term, then your horizontal asymptote is automatically y equals 0. And we kind of saw that when we did the 1 over x, and then we had the like 6 over x squared, the negative 3 over x cubed, or I can't remember what those were, but we put powers on those x's in the denominator and saw, hey, they're going to get bigger even faster, and therefore we're going to go to 0 even faster. Case 2, all right, n top power equal to bottom power. Then your horizontal asymptote is the ratio, that fraction of the leading coefficients. That's where we're going to be approaching as x goes to positive and negative infinity. And case number 3 at the end, now if the top power n is bigger than the bottom power, that means now the numerator is getting bigger faster than the denominator. We're heading off to infinity. So that means we're going to have a slanted line where one side goes to positive infinity, the other side goes to negative infinity, or in case it's a downhill line, then we just reverse it. All right, to find that line, okay, since there's no horizontal asymptote, it's called an oblique, or we're going to call it a slanted asymptote. You literally have to divide n of x and d of x. So d of x has to be divided into n of x, and you're going to find the quotient function, little q of x. That's why I didn't like that capital Q of x. And we don't want to look at a remainder. Don't worry, I'll give you an example of that in a second. Over here, determining your vertical asymptotes, now you need everything in factored form. Now, to find my vertical asymptote, you take the denominator factors and you set them equal to 0, solve them for x, and those are the equations of your vertical asymptotes. Now, these forms also give you something else, and I'm going to demonstrate that with the last example we did in the previous video. So if I use that 6x plus 5 over the 2x minus 3, this is polynomial form. X to the first over x to the first, leading coefficient ratio, 6 divided by 2 is 3. There's my horizontal asymptote. Done. Now, what else can we get out of polynomial form is that you might recall when we talked about polynomial functions, we discussed, hey, the constant is always your y-intercept. And I think we had 4 functions. They all had minus 4 at the end. We matched them with graphs A, B, C, and D. Same thing here. Your y-intercept is going to be the ratio of the constants. Now, if there is no constant at the end, you put a 0, put a plus 0 at the end. But if I'm putting plus 0 at the end, then I would have c over 0. I don't have a y-intercept, probably because my y-axis is going to be acting like a vertical asymptote. So in this case here, 5 over negative 3, or negative 5/3, is my y-intercept. And same function, we said to find the vertical asymptote. In the previous video, we said take the 2x minus 3, set it equal to 0, add to 3, divide by 2. We said it was 3 halves or 1.5. Now, if you take the top, well, we factored the top. We have to do something with this. If you factor the top and set the top factors equal to 0, that will give you x-intercepts. So 6x plus 5, we'll subtract over the 5 to the 0, divide by 6. x equals negative 5, 6, and that's my x-intercept. Now, another thing that may occur, doesn't happen too often, but it can, is sometimes you have a binomial factor same on the top and the bottom. And I'll discuss in more detail what happens here, but what you do is you create a hole in the graph. And we'll show you how you work through that. All right, so let's do some rough graphs without a calculator, no tables, nothing to help us out. We're just going to make a rough sketch. All right, so this is in polynomial form. So let's find our y's. Horizontal asymptote, we have x to the first, x to the second on the bottom, 1 smaller than 2, horizontal asymptote, automatically y equals 0. Then look at the constants, 1 over negative 3. There's my y-intercept. I have no idea what happened to my mouse there. Y's are done. Now you have to factor it. Well, the top's already factored. The bottom, we want to set that equal to 0, but we're going to factor it. So let's see, with 2x squared, I have to have a 2x and an x. With a minus 3, my only factors are 3 and 1. But I need for this to get up to be a positive 5. So since I'm subtracting, I need a number bigger than 5. I need a 6. So 2 has to be multiplied to the 3. And it's got to be a positive 3 to give me a positive 6. And then over here will be my minus 1. And just to check that middle term, we got a positive 6x minus 1x is 5x. We're all good. Set it equal to 0. Solve for x. So let's see, add over the 1, divide by 2, 1/2, subtract over the 3, negative 3. There's my 2 vertical asymptotes. X-intercepts, take the x plus 1 on the top, set it equal to 0, subtract over the 1. Negative 1 is my x-intercept. So now I can plot all this information. Now, I do have a little method to my madness here, and I've created some strange steps here, and I only created them because it helped students not to make mistakes when they look at graphs. So the first thing I tell everybody is that you are going to graph all your x concepts first. Your vertical asymptotes are going to be graphed as open circles on the x-axis, and your x-intercept will be graphed as a closed circle. So negative 3 and the 1/2 open circles, plot those first. X-intercept, negative 1, plot that right there. Now, the next thing we're going to do is something we learned back about that right-hand behavior. Because these are polynomial functions. Remember, we discovered didn't matter if it was an odd power or an even power. If your leading term was positive, your right-hand behavior is going to be positive. Well, even if you take a positive and divided by a positive, I still have a right-hand behavior that's positive. So in between all these x concepts right here, everything to the right of this open circle is going to will have positive y's somewhere up here. Between these two, they're going to be negative y's. Down here somewhere is my graph. Then these two, between here, will be positive. And after that vertical asymptote, that circle, everything will be negative. Because all of these occurred once. Therefore, the signs change positive to negative, positive to negative. So we determine the right-hand behavior first, alternate the signs, and we know where our graphs will be at. And I'll explain again why I put in those pluses and minuses in my graph. So with that done, draw in your vertical asymptotes. Okay, once that's done, we're going to put in all of our y concepts. So we're going to put in our horizontal asymptote at 0 and my y-intercept at 0, negative 1/3, right there. And that's a good thing. That point right there, between my vertical asymptote and that x-intercept, said we have to have negative y's. So perfect, it's in the right spot. Now when we start to build the graph, and again, here comes the reasoning for the pluses and minuses. we start with the points. So from this x-intercept, I go to this y-intercept, and I have to turn down and run right next to that vertical asymptote. Then from this x-intercept, I'm heading to the left, but now I got to turn and go up. And what would happen is people would stop right there and thinking, okay, my graph is done. Well, no, it's not. If you recall on our vertical asymptotes, on one side goes down to negative infinity, the other side had to go positive. So even though there's no points over here, I have to have a graph in these positive y's. So again, vertical asymptote, down to negative infinity on the left, then on the right, I'm going up to positive infinity. So I'm starting up here and just draw a curve down. And the same must be true over here by this negative. Right side of that vertical asymptote at x equals -3 goes up to positive infinity. Then the left side goes down. So I'm starting here and making a curve and filling in my graph right there. And that's my rough graph. All right, example 4b. Polynomial form, no problem. Do all your y concepts. Power of 2, they're the same. Leading coefficient ratio, 3 over technically a 1. So my horizontal asymptote is at 3. Y-intercept, -2 over -2. Okay, that simplifies to a 1. Done. Now we got to factor top and bottom to find your x's. All right, so the bottom, x squared minus x minus 2. Set it equals 0 to find my vertical asymptotes. Top, 3x squared minus x minus 6. Set it equal to 0 to find your x-intercepts. Now, when you're looking for these and you factor, once you're done factoring, if you get the same answers here for vertical asymptote and x-intercepts, we need to slow down and make a fix. Well, when we get there, I'll explain. So what two numbers multiply to be 2 and subtract to be a -1? How about a -2 and a +1? X minus 2x plus 1. All right, so x equals 2, x equals -1. There's my vertical asymptotes. Over here we got a graph. Let's see. We got a 3x and an x, and we're going to need a 2 and a 1, but we need 3 minus 2, and the 3 has to be negative. So 3x plus 2, and the 3x has to be multiplied to the -1 over here. No binomials are the same. Go ahead and solve. X equals -2/3, and x equals 1. There's my x-intercepts. So again, time to graph. X is first. Open circles at -1 and 2. Close circles, wow, that's going to be really close. And 1, really close. On the test, I guarantee you they'll be spaced out much better. Right-hand behavior. +3 divided by +1 is a positive. All these occurred once. There's no multiplicity on those binomials. All right, so just a sliver of a negative region. Back to positive. Even smaller negative region right there. Back to positive. Okay, let's see. Y concepts. Oh, check that. Vertical asymptotes. Put those in. All right, horizontal asymptote at 3. 1, 2, 3. Way up here. And we have a y-intercept at 0, 1. Oh, good. Check that out. Perfect. I'm in a positive y region, and there's my y-intercept at a positive point for my y-coordinate. Perfect. I know everything's looking good. All right, so time to graph. Looking at these points here. This point's got to run down next to that vertical asymptote. Then from this point, we're going to go through the y-intercept and then turn again real quick and go up. And again, remember, down on the left side, up on the right side. So I'm starting way up here, coming down, and then I got to flatten out at that horizontal asymptote. I'm not coming below here. The only way you graph below this horizontal asymptote in a positive area, you have to have an x-intercept where I'll come from below, cross the x-axis, and then go underneath the horizontal axis. Oh, wait a minute. That's happening right here. So I went up to the right of the x equals -1, so I need to go down on the left, come up and hit that x-intercept, and then turn, and I'm going to be underneath that horizontal asymptote right here. I'm still approaching 3. I'm just doing it from the bottom side. So here my y coordinates are going to be 2.8, 2.9, 2.95, 2.96, 2.97, 2.99999. Here it's the other way around. 3.1, 3.05, 3.02, 3.01, 3.00001. And we have our graph. All right, I'm going to stop the video because I'm afraid I don't want these to be too long.